Hello, and welcome to the second question on this worksheet, invalid and valid hashes. I think this question is a lot more interesting than the previous one because the previous one is just a mechanical thing of like, can you put things into a hash table? It's important to know, but it's kind of boring. This one, we're talking a little bit more broadly about hashing as a concept. So first thing I want to note is that oftentimes students have a lot of trouble in this class differentiating hashing with hash tables or hash maps. They think hashing is just a means to an end for hash tables, but hashing is a whole different thing on its own. As I alluded to in the first video, hashing is very important when we talk about cryptography, computer security. It has a lot of different applications. It's just in this class, we're pretty much only going to use it in the context of hash tables. But anyway, I just want you to differentiate hashing and hash tables, right? They're different things. And if you take a class, especially like 161, you'll learn more about this in the future. Anyways, let's go on to this actual question here. So it says for both parts below, we're trying to hash the following class. So this is just a simple point class, right? It has an X, it has a Y, and it has a static count. So basically what that means is every time we create a new point object, this static count is going to get incremented. So it's just a record of how many points we've created in all time, and each one has its own X and Y. If you remember back to the first couple of weeks of the class, we had a lot of worksheets that were very similar, where you would have a class that had a static count and it would just increment by 1 every time. It's the same thing going on here. Generally, relatively simple class. Mostly it's just keeping track of these two variables. Okay, so we want to create a hash code for this class, and we want to see if it's valid. Now, what does it mean for a hash code to be valid? There's two main things. One is basically that two equal things hash to the same thing. Right? That means that if you have something like maybe x equals 5, this is in pseudocode, by the way, and y equals 5, the hash of x should be equal to the hash of y, right? If two things are dot equals, right, they should have equal hash codes, right? This is a simple example with integers, but you could also imagine, let's say that you had, here's an example. Let's say that you had a dog object, and you consider two dogs equal if they have the same name, right? But let's say that the dog object also has an age field, like an int age. So every dog has a string name, it has an int age, but two dogs are equal if and only if their names are the same. Well, then you could have two different dogs with two different ages, but the same name, and they should hash the same thing. That's basically what's going on here. Yeah, another thing to note here is if you remember in project 1, when you were creating the equals method for implementations of the DEC interface, one thing that the style checker may have told you is you're not allowed to have, or that you need a hash code corresponding to your equals code. You may have noticed that, and we told you just to ignore it. The reason that was happening is because whenever you create a .equals method, you should also have a corresponding .hashcode method that makes sure that two things that are .equals have the same hash code. It's a fun fact for you if you were confused at the time about that. But anyways, moving on, the next thing that that you need for a hash code to be valid is basically that a given object hashes to the same thing every time. Okay, what does that mean? That means if you have an int, for example, or some object, let's say you have x equals 5, and you print out the hash of 5, and then you print out the hash of 5 again, it should be the same thing. In other words, between any two calls of a hash code to the same object, as the object remains unchanged, you should get the same hash code, right? Same thing every time. Okay, that's what it means to be a valid hash code. I also want to point out something that is also important is a good hash code. So there's only really two rules to have a valid hash code, but there are more rules if you want to have a good hash code. So one is it should be fast to compute. You don't want your hash code taking linear time to compute. The whole point of a hash code in a hash table, for example, is to compute it quickly. You also want to minimize collisions. Because again, if you're using something like a hash table, you want different hash codes so that you get a good sorting pattern, basically, in all of the buckets. So this is what it takes for a hash code to be good. This is what it takes to be valid. This is what it takes to be good. Notice in this question, we are only asking you if the hash code is valid, but I'll just, for sake of understanding, kind of talk about if it's good or not too. Okay, so let's just start doing these problems now, keeping these rules in mind. Are the following hash codes, which of them are invalid? So the first one is a hash code, and it just prints the sum of x and y for a given object. This is not valid. Why is it not valid? For a lot of reasons, actually. So this kind of actually doesn't even break any of these rules. It's just so fundamentally wrong. First of all, a hash code, like a hash number, it returns an int, right? And you'll see this is void. It doesn't return anything. It just prints something. So it doesn't even fit the basic criteria that the whole point that a hash is just a number, basically. So that one's kind of trivially incorrect. But let's move on to the next one. So hash code, basically all of this second one does is it creates a new random number generator, and then it pulls random numbers and it returns them. So each time you pull a random number, and that will be the hash. Is this valid? The answer is no. Why is it not valid? Because it breaks this second rule here. A given, whoops, should be an end there. A given object needs to hash to the same thing every time, right? So if you have an object and you hash it and you use this hash code, then you hash it again. Because you're just pulling random numbers every time, you're probably going to get a different number every time. So you're not guaranteed to get the same number every time. So this doesn't work. It's non-deterministic, basically. Okay, third one, basically a hash code, return x plus y. Okay, so if you return x plus y, two equal things need to hash the same thing. That sounds like they would, right? If you had two different points and they both had the same x and the same y, they would hash to the same thing with this. And a given object needs to hash to the same thing every time. Well, there's nothing random here. This is deterministic, so it will hash to the same thing every time. So the answer is yes, this is valid. And the question doesn't ask you about this, but I want to pose, is it good now? Well, there's a few reasons it's not that great. So it is fast to compute because all you're doing is you're adding two values together. That's not a big deal. However, this does not minimize collisions, right? In other words, what we mean by minimizing collision is we don't want to have a lot of objects that are not equals, but hash the same thing, which can happen, right? Well, let's see if we can come up with a collision. Basically, imagine you had a point and it had an x, an xy, and maybe the x is 5 and the y is 2. And let's say you had another point with an xy. Well, if this one has an x of 2 and a y of 5, clearly these are not the same point, right? So they're not equal, but if we look at the hash code, they are going to hash the same thing, which is a collision, right? This is one of the reasons this is not a very good hash code. Another thing to note about this particular hash code is there's an issue if you try to change the object when it's inside of a hash map. And basically what I mean by that is, let's say you have a hash map and let's say you have an object and, you know, the xy, let's say the x is 0 and the y is 1, right? So it gets sorted into the first bucket, something like this. Okay, so the problem here is that if you then change x or y, you might change the bucket you're supposed to be in. So if you change y to be 2, like you mutate the object or something, this is now sorted in the wrong bucket, which means we're not going to be able to find it, because if you try to call get or something like this on this hash map, get is going to create the hash code, which is 2. It's going to mod 2, and it's going to look in bucket 2 for this thing. This is a big kind of lesson of hash tables. You might hear people say, if you put something to a hash table, you cannot modify the object after you do that. And this is why, because it can result in changing the hash code, which then changes what bucket you're supposed to be in. Anyways, moral of the story is it's a valid hash code, but it's probably not a very good one. Okay, next one. The fourth one. Okay, this one just returns 4. That seems pretty dumb, right? But let's look at our rules. So 2 equal things hash to the same thing. Well, yeah, 2 things that are equal would hash to the same thing because everything hashes to 4. So this is met, strictly speaking. And then a given object hashes to the same thing every time. Again, this is deterministic. It's not random. So the same thing would hash to the same thing every time. It would just always hash to 4. So this is actually a valid hash code because it meets the criteria. Now, is it a good hash code? And you can probably tell me, no, it's not particularly good. It is fast to compute, I can give it that, but this does not minimize collisions. In fact, it maximizes collisions because literally everything is a collision when you do this. So not a good thing. Another thing to think about here is that the bucket we place something in a hash table in is determined by the hash code. So if the hash code is always the same, that means we're going to put everything into the same bucket every time. And at that point, if we're putting everything into the same bucket in a hash table, really we just kind of have a linked list rather than a hash table, and we don't get any runtime benefits. So that's another reason it would be bad. It's technically valid. The next one, count. Is this valid? So do two equal things hash to the same thing? They would, because two equal things, right? If they're just using count as their hash code, the count is the same between all of them. The problem is here when we say a given object hashes to the same thing every time. Well, that's not necessarily going to be the case, because you might have an object, it's an XY. Again, let's say it has 5 and 2 as its variables. It's going to hash, in this case, to whatever count is. And then if you change count, you create another object. Without actually changing the contents of this object, you've changed the hash code. So in that effect, it's almost kind of the same thing as this like random hash code, where you could go back, do some other operations, then come back and it will hash to something else. So this is not a valid hash code. Okay. A final little bonus question here is, suppose we know all the points of X and Y have coordinates anywhere from 0 to 10 inclusive. We want to write a good hash code. Okay, so first thing we know is we know the hash code needs to be deterministic, because if the hash code is not deterministic, it's not going to hash the same thing every time. Another thing we know is that we need to have two equal objects hash the same thing every time. Sure. Okay, and if we want to have a good hash code, that needs to be fast in compute. That shouldn't be much of an issue. But importantly, we want to avoid collisions. So basically the question here boils down to, if we know that X and Y are consistently going to be from 0 to 10 inclusive, how can we generate a hash code that's going to avoid collisions, right? Such that two things aren't going to hash the same thing over and over again. So if you remember before, we had the example where you just added X and Y, and that was a problem, because if you have something like this, right, 5, 2 and 2, 5, these are not equal, but they do hash the same thing, because when you're just adding these two things together, you get 7 for both of them. Okay, so we want to avoid this situation. And the way that we can probably do this is we can basically just kind of weight one of these things, right? In other words, we can multiply one of these numbers by a constant such that it will never it will never make a difference, right, of this other thing. In other words, one thing you can imagine is, well, imagine if you looked at this number not as 5 and 2, but as just like 52, right? Like you had 5 times 10 plus 2 or something, right? Well, now you've made it such that there's no collision here, right? Because this one would be 25 by that same reasoning. So in other words, what we're doing is we're multiplying the X coordinate by 10, and then we're adding the Y coordinate. Okay, that's a great starting point, but it's not quite perfect for us, because keep in mind, coordinates can be between 0 and 10 inclusive, meaning that there's 11 different values that they can take on. This method works great for when there are 10 different values they can take on, but not when there are 11. So all we have to do is just adjust it. So if we have something like X times 11 plus Y, this is going to give us a good hash code, and no 2 points in this hash code are actually going to hash the same thing, right? You can prove this yourself or try putting some things in to a hash table if you want to be super sure that it won't work. But yeah, that's how you might generate a good hash code for that. That is the end of this question. So Soham, I believe, has already made a video for the third part of this question, so I will hand it to him to finish out this worksheet. I hope this helped.